Everybody's Tyler here at the First in Texas Championships, checking in team number 8177 Vector. This team was number one going into Texas States, and wow, what an incredible team. It's only kind of like your second year because you started on 2020. You only got to play one competition, and you have been taking Texas by storm. We're hearing about you all over the first world right now, so can't wait to talk more about their robot. And to help me do that, by the way, I have Roland, Akarsh, Murad, Connor, and we'll be following that cargo journey as we go through. Just pay attention to some of the design that's gone into this, especially as a second-year team coming in. Really great aesthetic design, but very functional as well, too. So we'll talk more about this coming up here on Behind the Bumpers.
Your destination for FIRST content, updates, and gaming.
Welcome to the fun.
FIRST Updates Now is supported by Stryker Careers. Stryker's commitment to medical device technology innovation has made it a top career destination for those in FIRST. FIRST alumni and mentors are given top priority in their internship and career applications. Come create the next medical innovation that saves lives at careers.stryker.com. If you are planning on attending the World Championship, come meet others in the fun and FRC Discord community with our combined meetup on Friday, April 22nd at 11 a.m. local. Location will be announced closer to the event, and you can stay updated by following in either the fun or FRC Discord.
So starting out on your robot here, let's talk about your intake. Talk about what's gone into it, what's worked, what hasn't worked, and why'd you choose to go the way you did?
Right, so our initial choices was to make a flexible intake that could take hits. Because we know that's a big problem whenever you're playing defense, and so, oh, sorry.
Why don't we start over, I'll bring it back. Yeah, make sure you keep that nice and tight, right?
Sorry.
You see how I was talking about, kind of going like that?
Okay,
yeah.
I'll keep track.
No worries, so here we go, 3, 2. Let's start on your robot, talking about your intake here. Talking about what's gone into it, what's worked, what hasn't, and I'd love to hear more about how the compliant intake has been working out for you too.
Right, all right, so starting off, we wanted a really durable robot coming into the season, because we know intake takes a lot of hit during defense. And so we decided to go with a 4-bar linkage, which are pretty common this year. And so if we want to actuate it down. All right, so we have our 4-bar intake with the first row being all compliant. So once the ball touches it, it immediately just intakes it right in. Our second ball, we have some mechanism wheels here, which helps center it and helps singulate it into our elevator right here. And so all this is powered by 775, which is powerful enough to just make sure the ball intakes it right away.
When you were looking at from competition,
right.
Have you guys made any changes to your intake at all?
So in our first competition, we actually had the mechanism out front because we thought we would want to vector it in initially, but that didn't really work out, as sometimes if it only hit the mechanism, we would just push the ball away. And so we made the swap right there.
I'm going to say I'm a little disappointed. It's not all vectored intake wheels. I mean, it's kind of going against your name a little bit, but
yeah.
We'll forgive you. A nice aesthetic.
I have some, you know?
Yeah, that's fair on that. Well, let's keep moving on your robot. We're going to go into your elevator mechanism, and Karsh's going to talk a little bit more about that. And I'd love to hear, too, like, are you doing any sensors at all? And then how did you try to mitigate, like, jamming as well, too, up cargo?
Okay, so our elevator system is basically it's entirely passive as far as singulating goes. So after stuff gets intaked, it hits these two polycarb plates that we cold pressed at an angle, and then there's this bar that reaches out front to on top of those. And between these two, it really gets sucked right in and goes in one at a time. And then as it gets past that, we have a hex bar here, linked together with pulleys and belts.
Sure.
And this is all on one 775. So basically, because we never want to have where like only one runs at a time, so we just connected all of them mechanically. So as you can see, when one spins, all of them spin. So that ended up being really useful. So after it gets intaked in, it hits these, it gets singulated. We have a row of churros here that we shrink wrap orange to make them look cool. And this timing belt is actually something that grips the ball and moves it up. So the timing belt, between the timing belt and the churros, the ball moves up to the shooter. And one of the design choices that we had to make was adding a kicker wheel row or not, because you have to get your balls away from your wheels so that they don't shoot out when you try to spin them up. So what we decided on was just having them go all the way up, we reverse direction, They spin up, and then we shoot. As far as sensors go, we don't have anything at the moment in here, but the plan, because spinning backwards takes some time, is to add a beam brake sensor near the top so that we can just stop the elevator as soon as the ball gets right before the Coulsons. We also plan to add some kind of auto rejection if we intake the wrong color, and that's going to be just a rev color sensor somewhere around here. As far as iterations go, the only real change we've had to make to this to counteract jamming was these X compliant wheels here. So we picked bigger compliant wheels than the 3-inch ones we have on the intake, because we thought it would be necessary. But turns out when we looked at it, these were actually getting torn up and being like pressed into like the compliant wheel like halfway. So what we did is we just cut off all those ends of the spokes, cut off the outer rim, and now it's this weird star shape, and it actually works really well.
I've seen a lot of teams go that route too, and I agree. It's been working out really well for teams. Can we see a piece of cargo come in first, and then we'll go over to Murad, who's going to talk more about the shooter as well.
Sounds good.
I think it's a great segue to go into it. So let's talk about your shooter here. We talked a little about kind of the pre-shooter going into it, but talk to me a little about like some of the testing you've done. Where do you like to shoot from? Where's your sweet spot in the field?
Well, since we have a static climber, we obviously don't have the biggest range ever. So we like having the middle of the on the tarmac line. That's optimal for us.
Sure.
And currently we have 2 wheels. One of them we call Little John because they're smaller wheels, and then Big John, the back wheels.
All right.
And we've just been like tuning it as like effectively as we possibly can to shoot from any angle possible. And currently we've been having a really good calculation from feet like 1 to 6, where the linear regression for it is pretty consistent. So we can shoot pretty consistently from there. Anything past that, we're still trying to work on that.
Yeah.
It's kind of harder than having like a moving hood, but right now it's pretty good. What we do is we have a webcam right here for detecting balls and then sucking them in, and then back here we have a limelight to detect using basic geometry the distance from the hub, and using that distance we feed it through a equation, which gets the current RPM we need for both wheels. And RPM is also a challenge for us, trying to code that PID in. But eventually it worked out. We made it in one day, the day before competition.
Oh, there you go.
Yeah.
I mean, nobody would ever know, and you guys have been doing so well that
Yeah.
I don't think anybody outside would guess something like that.
I was a bit worried, but like after that last match, it was very nice. It worked very properly.
Really cool. Let's go into your climber next. Connor's going to be talking about that. I'd love to hear about the climb sequence as well, too, and if we can demonstrate your climb sequence, that'd be great.
Right. So our climb is pretty simple. All we do is reach all the way up, grab the mid rung, and then these static climbers actually fold inward, thereby allowing us to get above the mid rung. And then once we're above, they just snap back, and it grabs the mid rung. And then we repeat that process all the way up into a traversal. And yeah, so that's basically the climbing sequence. We actually had a lot of change to this, particularly with this giant triangle right here.
All right.
Because when we were designing this, initially we had just a single 2x1 bar connected via a T-bracket. However, while testing, we realized that the T-bracket would actually bend and causing the whole entire climber to bend, which is not something we wanted to deal with after every single match. So our first initial thought was, okay, how do we fix this? And then we ended up coming up with a giant triangle. That way it would spread the load more evenly. We also decided to add hard stops. It's something that we saw from fellow OA team, 1339. They had these hard stops that we really liked, and we thought, wow, that was genius. It's so simple, and so we implemented it. And so all of this was basically to have redundancy in the system so that nothing could ever break. Because replacing one of these climbers takes a lot of time and a lot of effort we do not want to be putting ourselves in during a competition. And then our last iteration, so I should clarify, our second iteration, the one where we installed the giant triangles, they actually weren't welded. They were attached via bolts to the front and to the back. However, after channel view, we realized that the climbing system would actually bend. Right? So while these triangles worked in mitigating most of the bend, it still ended up bending, which is why we see this hard stop kind of bent outwards. And it's not something we wanted to deal with going into Pasadena. So in Pasadena, one of our mentors contacted this local, a local company called Race Source.
Sure.
And basically they looked at this and said, okay, here's the design flaws, here's how you fix it. And then he went ahead and MIG welded all of these plates together while teaching us a proper design on how to mitigate the forces acting upon a climber when you're swinging back and forth and traversing up the climber.
Well, let's see the climber deploy here and talk about the stages as it goes through it.
Right. Okay. So stage one, we reach all the way up, grab the mid bar. Right, and as you can see, we actually stop a bit. This is to be within the not frame perimeter, but the height limit. And so we actuate out. Well, actually no, we go back down. We go back down. Right, and these come down when these go down, and they pop up. And then we actuate out. And then once here, we grab the rung, and then we pull all the way in. Right, and then these slip back out. And then we do that again for traversal. Right, and then on the on the traversal bar, we bring the intake up so that we can prevent the intake from smashing into the wall, causing damage. Because while it is pretty sturdy, it is made out of polycarb, and we don't want to be damaging it any more than we have to.
Let's start to wrap up on your robot here and talk about a couple other things that Akarsh wants to cover. We're going to talk about some electronics, a little bit of modification to the drive base as well too from Andy Mark. So I'd love to hear more about that and anything else you want to cover.
Okay, so I'll start off with our chassis here. So this is the AM14U5 chassis included in this year's kit of parts from Andy Mark. And so being a second-year team with high aspirations, we had to decide between our different chassis types. And an option was definitely Swerve as the elephant in the room. But we decided with all the new things we're trying this year, like all the PID, our shooting, pneumatics never used before, we decided it was unnecessary. If we want to, it's definitely beneficial, but we decided we'd definitely focus on other things before complicating to Swerve. So, but what we did do to our kit chassis is we swapped the front wheels and the back wheels with Omni wheels instead of the high grip wheels. Because we have a drop center, we're mostly on that middle wheel, so we left that as the high grip ones, but we turn on the front and back. So those are Omnis that have rollers on them. And that really allows us to maneuver in insane ways, and it really helped our code with our PID turning and stuff. It made it super accurate. If we move around to the electronics here, so I think the newest system on a robot this year has been pneumatics. That's the newest iteration, that's the newest thing we've done. And it was always really daunting to us in the past because, like, I don't know, pneumatics is a scary word. But but it actually worked out really well. So basically we have 4 cylinders total on this robot. We have 2 right here for the intake. When they actuate out, they move the intake down. When they pull back in, they move the intake in. As you can see, we have the little tips here and here that move it, like so. Back here, we have 2 more for the climbers, as we already showed. And these are 1 1/4 inch bore, I think 4-inch stroke cylinders. So we definitely use some old spreadsheets that we found on Chief Delphi to calculate for what cylinders we would need. On these cylinders, we have flow regulator valves to control our speed, especially on the intake. Because what we didn't account for was that on one side of the intake, we have a 775, and that actually changed up our weight. So when we came out and came back in, it wouldn't come back evenly, and it would actually end up twisting the intake a lot. So what we did to counteract this, we put flow regulators on all of these cylinders, and we tune that until it comes back and out at a relatively even pace. All our electronics, all our pneumatics electronics, if you can see they're missing, they're actually on the base pan on the robot. You can probably get a good look at them over here. We have our 3 tanks, 3 standard air tanks. We have our solenoids in the middle, and then we have our other stuff wired up to this back plate here. As far as our electronics go, I think it's standard FRC electronics, and then the newest things we did were switch to this Ethernet switch. We found out through Open Alliance, we love you, Open Alliance, we would not be here without you. We found out through Open Alliance that the second port of this radio is actually bugged, the universal FRC radio. So what we did is we got an Ethernet switch, and now everything runs to the switch, so all we have to use is the first port. This allows us to use our Limelight while we're tethered, and it also lets us tether easily instead of having to take our entire back plate off.
Well, as you mentioned, Open Alliance is a great resource. Definitely recommend to check out for teens. There's close to 50 teens part of that now, which is really cool. Vector, really appreciate your time, 8177. Talking about your phenomenal robot here. I know you've had a couple rough matches as we're filming this, but you looked really good, though, and that's the important part for it.
Definitely.
So we wish you best of luck throughout the rest of this, and hopefully get to see you at World Championships as well. Thanks a lot for taking the time.
Thank you.
Thanks to Stryker Careers for their support in this video. Stryker's commitment to medical device technology innovation has made it a top career destination for those in FIRST. FIRST alumni and mentors are given top priority in their internship and career applications. Come create the next medical innovation that saves lives at careers.stryker.com. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.